Greetings everyone. Today our group will be presented about the PBL project Anomaly Detection and Quality Control. Our team members is led by Muhammad Aiman bin Muhammad Omanetin and his role is a presenter and also the data analyst. The next person is me, Nurul Atira binti Muhammad as a group secretary and my role is a quality control chart expert. The next person is Siti Nur Natasha binti Jaafar as a scribe and her role is a regression model builder. And the last person is Yap Sin Yuan as an observer and also a
Among
presenter.
some of our objectives are to identify the steps to enhance the quality control process. And this can be done by minimizing factors affecting product quality control, which also can be done by identifying outliers using software, monitoring defects via statistical quality control to improve our product quality, and also performing simple linear regression, which allows us to get the model relationship between variables. Right here is an example of how we can use statistical quality control on Excel. So for example, here you can see our quality control process on operators with regard to length. As you can see on the chart above me, the X chart here is under control, while the X chart below me, based on S, is out of control. This because there are outliers present, as you can see on the circles, which is surrounding above the upper and lower control limit. So the main purpose we use Excel is to problem solve by detecting the outliers using the program and determining if it is significant or not.
We actually had employed multiple tools for our analysis. Other than utilize control check in Excel, our team members Natasha have utilized our programming to conduct linear regression, yielding similar results to those obtained through the control chart analysis. The first chart displays the width and height measurements for all three operators, while the second chart specifically focuses on the measurements from the first operator in terms of height and width. Based on the provided data for operator 1, clearly with the height versus width measurements, the p-value, which in this case is 0.390041, which is a crucial factor to consider as it shows the goodness of the fit of the model to the data. From this, we can conclude that there is no significant positive relationship between width and height as our p-value is equal to 0.390041, which is larger than 0.05. Two of these charts display the data of operator 2 and 3, specifically in terms of height and width. Based on the raw data for operator 2, particularly the height versus width measurements, it is important to highlight the significance of the p-value. For this run test, the obtained p-value is 0.517. Therefore, we can conclude that there is no significant positive relationship between the width and height because the obtained p-value, which is 0.157, is larger than 0.05. As the result of the regression on three operators were all not significant, you can say that all the parameters that had been recorded are dependent parameters. They will not affect another parameters as they increase or decrease. Therefore, we can conclude that all the chart that have been shown is abnormal. In conclusion, operator 2 has the closest value to the control limit. This means operator 2 has the most accurate parameters to produce the heavy vehicle parts as operator 2, also a good quality operator compared with another two operators. In a nutshell, operator 2 can be considered in maintaining the product quality while optimizing the process to improve the product quality. Actually, we can make quality control chart using RStudio, and these are the example of X bar chart and R chart of operator 1 by using RStudio.
Thank you.